Yeah. Is the screen visible to all the participants?
Yes, sir.
Thank you. Thank you. Yeah. So in today's session, as HOD sir said, we'll be covering very most important topic from the quantitative aptitude point of view, that is the averages and percentage, right? So these are the most popular domains from which you get the questions, let it be your interviews or many times in your other quantitative aptitude tests, right, in different examinations. So today's point of focus will be these two topics, averages and percentages. And I will make sure that by the end of this lecture, which will be lasting maybe around approximately about 1 hour or maximum by 1 hour 30 minutes. So in this whole session, we'll be looking forward for every minute details for these two topics, that is averages and percentage, right? We'll start from very basics, right from zero. So anybody with absolute zero knowledge of average and percentage, I guarantee you that by the end of this session, that person can understand the holistic view of what is an average, what is a percentage, and how can we operate when asked these questions from these domains, that is averages and percentage. Okay, so we will look forward in all the fundamentals. We will make our fundamentals strong to encounter any type of the problems asked, let it be in interview or in the examinations, right? So examination point of view, there's one thing that especially be it any topic in quantitative aptitude, what I feel is the practice is what will make you perfect. The number of questions, the type of questions, the varieties of the different types of questions, let it be any topic, right? Let it be percentages or averages or numbers and decimals or age, blood relations, whatever, right? So in quantitative aptitude, the more number of questions that you solve, you get better hang of it, and you get a better hold of it to solve variety of problems. So the perfection will come only when you have number of problems solving from the various test books or any type of resources that you can put hands on, right? So but in this session, in this limited time, 1.5 hours, our main focus will be how to understand the fundamentals of those topics, that is averages and percentage, to encounter and solve those advanced application oriented problems. So like I said, I guarantee you that after this session, we will be able to handle every type of problem which can be asked from these two uh, topics, that is averages and percentage. So our main focus will be fundamentals. How can we understand, given any question, how can we understand that question? How can we calculate averages and percentage? So with this short note, we will go ahead and is our average, right? Okay. So average, as you can see on the screen now, that average can be basically divided into three things, right? Four things, four possible averages we can compute: mean, median, mode, and range. Now, few of you people might have encountered these words, right? Maybe in your previous education. But again, like I said, we'll be starting off with real basics. So we will look upon these basics again, understanding what are these, what is a mean, what is median, and what are the differences among them, among these four types of averages, right? Because first things what comes in our mind when we talk about average, right? So something like average of let's say when we have 10 items, average of those 10 items, something like that. But there are varieties of averages, right? For example, like how a percentage is completely calculated or a percentile is calculated, there's a difference in it. Likewise, how a average is calculated, there's a difference. There is a these four basic types of averages that we can compute. So starting off, let's start with one-liner definition of these four types of averages, that is mean, median, mode, and range. Right. So mean, what is mean? The total divided by how many? that will give us mean. So basically, the first thing that comes in our mind, how average is computed. For example, average of your marks, right? Average of a population. So the first thing that we come into mind, that is actually the mean that we calculate. We will look upon few examples also as in when we proceed. But right now, just focus on what these terms mean, right? How do we define these simple terms? So mean can be defined, it's the total divided by how many. Median. The median is the middle number in the size order. So whatever the size, whatever the quantity, the items that we have, so what is the middle number? It will be our median. That is one way of computing the average. And again, now, what is a mode? Mode is another way of computing the average, which is actually the most common one. We say, right, let's take an average from the class of the students. So, what is this? That can, for example, what game should we play in the next gaming session? I'm just giving an example. So, few might have pitched to game, let's say game one or game two, some say game three. So, likewise. So most common of that is collected, or maybe majority of that is computed, selected, and that will be our, we say, right, on an average, we should go for this particular game because most of we have selected that, right? So that is another way of computing an average. So mode, that is the most common one. The fourth and a rare type of average that we see, that is a range. Now, what is this range is? Range is actually the how far apart our values are, right? From the set of values, we will be having few lesser values. Some might be a bigger values, right? More values. So what is the range? What is start point? What is the end point? So that is the range. That is one way of computing averages. So with this basic definition, let's move ahead and take an example of each and every type of average that we have seen now. Talking about the first one, mean. Like we defined, it's the total divided by how many. So I have a simple example here. Let's say we have 5 children with their heights recorded in centimeters. So which goes something like this. We have these 5 values: 132, 141, 118, 120, and then one again 118 centimeters. These are the height of let's say school kids, right? Then the question is, what is the mean, right? This is one way of calculating the average. What is the mean of this? Okay, now recall the definition of mean. Mean says total divided by how many. So as you can maybe rightly pointed out, that it is the total of these values divided by how many. So we have 5 here, right? So it will look something like this. We have these values: 132, 141, 118, 120, and 118 again, divided by how many? That is 5. So total divided by how many? That will give us the mean average. Now, the whole of this addition of these values, as you can see here, brings down to 629 out of 5. When we divide, we get something like 125.8, right? This was a simple example. Now let's move forward to understand the second type of average, that is our median. Now median, in order to for you to understand what is the difference of this mean and median, let us take the same example so that it will be easier for you to understand the minute difference of what is a median and a mean. So let's define the first thing, that is the definition of a median type of average. That is the middle number in size order. If you can recall, we defined the median as the middle number in size order. So let's take the same example. What is the median? So in this case, when a question is what is the median, go back and recall what is the definition. We define the median as middle number in the size order. So middle number in this size order is when we sort it out, right? Because in order to get that median, we have to properly organize our data, right? size or the quantity or the values or the items, whatever the example can be. In this case, it is the measurement of height. So whatever your data is, you have to first sort it out, because only then you will have the middle number from the set of values that we have, right? So this is our original data: 132, 141, 118, 120, and then 118 again, which is not so sorted, just a random data. So in order to get the middle number, we have to sort it out. Let's sort it. So after sorting, we get this value, right, from smaller number to bigger number, that is from the ascending order. 118 two times, because we have two students with the same height, 118 centimeters, then 120, 132, and in the end 141. So now we can go ahead and see what is the middle number in our size, which is ordered. Now, what if you can clearly make it out? The middle number is 120. Right? So when we talk about the middle number, the median becomes 120. So now you can see the difference that we had when we computed the average for mean, and now what is the value that we have computed as an average when we had median. So if you can recall, the average value that we got was something around 125.8, if I'm not wrong. Yes, 125.8 that we got, right? Yeah. So this was the method, this was the value that we got for the method mean type of average. And when we went ahead to discuss the median, the value that we got as an average was 120, exactly a round figure 120. So you can make it out that a median is slightly less precise than a mean type of averaging, right? So when you have very critical data wherein every decimal value is important, you can choose to go ahead with the finding the average of that particular data with the type of mean computation, right? You can use mean method there instead of median, because median will give you a rough approximate value, a whole figure, but median, as I said in the slide, median will give you a whole roughly approximation value, but mean will give you exact average value depending on the data, right? So area of application can be different in different possibilities. Let's get into the third type of average, that is mode. Now recall the definition again. The definition was the most common one. Let's take the same example and compute what is the average by taking the technique of mode, right? So we have that same example: 132, 141, 118, 120, and 118. Okay, so I think this example must have fit into your mind by now. So the question is, how do we compute the mode, right? So in order to compute the mode, we have to select the most common one. As the definition goes, the most common one, right? So as you can see, there are two data items, we can say, which are same value. So 118 is the most common one. And so in this case, our answer will be average is 118. Now you can still see the difference that we are getting, right? When we compute the mean, when we compute the median, when we computing now the mode, right? So I hope you found the difference here. Let's move ahead and check for the fourth type of average, which is range, right? So as the name suggests, range, it will give us the range of what? Range of something which has a start point, range of something which also has an end point. In between whatever lies is our range, right? So to define it, it is how far apart your values are, right? So that's how a range can be defined. So let's take the same example and compute the range for the example. Now again, in order to find the range, we should know the lowest value, also the highest value. We should know the start point, we should know the end point, depending on the data that we have, right? So for that, we have to select or compute the smallest as well as biggest values amongst the set of data that we have. So in this case, as you can clearly see, 141 is the biggest number, and 118, which is actually two times, is our smallest number. Now, let's go back to the definition. How far apart your values are. Now you can clearly see how far apart our values are. So this difference of biggest value and the smallest value will give us the range, right? So fair enough. Let's compute it. 141 and 118 are dash apart. Now what is this? What is this dash? This dash will give us actually the difference, right? The difference of the smallest as well as the uh, biggest value. So when we compute it, that is biggest value is 141 minus 118, which is the lowest value. The value that we get is 23. Now we can say that 141 and 118 are 23 values apart, right? They are 23 values apart from each other. So that becomes our range, right? 23 will become our range. This is one way of computing average, which is not mostly used. The area of application depends on the problem, what type of problem it is, and whether do we require average type of, the range type of average to be computed there, right? So with this, I think you must be clear with what is an average, first of all, what are the different types of average, and what is the difference among these four different types of average, right? So with this, uh, we should go to the next topic, but to make you more well versed with the type of problems, we will quickly have type of questions, different type of question which you can get for the average type of topics. So let me show you another way of doing it. That is, let's say we have something called discrete series. Discrete series, as you can say, it's a simple series of the values that we have. So to compute that, there are different methods. Let me, to make you more of this understand, let me go back and discuss with the scratch. Now, as we see in the mean, what is mean? Simple, there are different types of mean, right? Don't worry about this complex words here. We will only focus on the essentials of this lecture, which will be strictly with respect to the average, right? So when we compute the average, there are few direct methods and there are few shortcut methods as well, right? So depending on the problem, we sometimes use direct method, sometimes we use indirect method, which is actually a shortcut method. So when we talk about the direct method, in individual series is the exact, just to give an example, the exact problem that we saw now, the height of few people, few kids, that can be a perfect example for our individual series data. Now, how can we compute average with the direct method? So this is the formula that we usually use, right? You must be already familiar with this formula. Let's say we have average has to be denoted by x dash. X dash denotes the average, which is the mean average, mean type of average. So let's name it the arithmetical mean, right? Arithmetical mean is another type of a mean. So x dash is the arithmetic mean that we want to compute by using a formula which is actually a summation of all the values of the item of whatever the data that we have. That data is actually in the form of an individual series, right? So let's take the same example, right? Height of those five kids. What we did, we summed all the heights and then we divided by some number. That number was actually the total number, right? If you can recall, total divided by how many? That how many is the number of observations, right? So our formula will something looks like this. That is x dash, which is arithmetical mean, is equal to the summation of all the values divided by the total number of observations, right? So let me go back to the slide and show you that how can we do it. So this is the example, right? Example we did, right? Let me go to that slide. Yes. So as you can see here, mean we defined as total divided by how many. So we computed and we summed all the values and then we divided it by total number, that is how many, which was 5 in our case, and which gave us the total of this divided by 5, right? Total of these whole 5 values or items or measurements, whatever you want to call it, divided by the number of observations, which is 5, right? And the result was something 125.5. So it's just an example. So on similar grounds, this is our direct method. Now, what is shortcut method? In order to understand the shortcut method, we have a concept called something called deviation. Now, the deviation is actually it's the value which is taken from the assumed mean value itself, right? So let's say we have this factor called d, small letter d, which is actually a deviation of the all the items from the assumed mean. That is the mean that we have got from the whole data, actual data, right? And we will name that assumed mean as capital A. So in that case, the shortcut method is the sum of all these deviation divided by the number, total number of observations. That's it. That will gives us the uh, arithmetical mean of the values or total values that we have. So that's a shortcut method. Sometimes handy, sometimes not. People use it, some people don't. That's a different thing, but it can be computed is the whole point, right? So likewise, there are different discrete series for different values. Then again, in discrete series also we can compute direct method, like the formula, like I said here. So let's not get too much into it, but this is just to make you aware that these can also be the type of or variety of averages that you can encounter. Then the again shortcut method for discrete, and then median, we already defined it in more simpler way, and calculation of median and so on. Right. So let's have a simple example again, that calculating the mean of this data. Right. We have this 7 items, that is 16, 18, 13, 15, 19, 17, 20. Assume it anything. Assume it that these may be your I marks out of 20 something, right? Or it can be anything. It can be the price of some item, some object, right? Whatever, you take it to your own example. So this can be whatever values. So irrespective of what values it is relating it to, let's consider it as just numbers. We have to compute the median of it. So recall the definition that we have defined for the median, right? I hope you can able to recall. Anybody? I would request the participant, anybody who can recall the definition of median that we defined before we actually calculate the median here. Yeah, any participant?
So median is the middle value of the given numbers.
Very good, Yashaswini. Very good. You recall the definition exactly. Median is the
Arranging
mid.
the terms,
Yeah, go
sir.
ahead. Yes, Divya, go ahead.
Arranging the terms, and the middle one is the median, sir. Arranging the
Very good.
terms.
Very good. Very good. So both of you are right. Yashaswini said that it is the middle term. But how do we, the question is, how do we get that middle term? That complete, Divya completed the definition of it by arranging that, whatever the sequence, the data that we have, the order, the size that we have. So both of you are right, and both have to be incorporated. We have to first order the sequence, then we have to look up to which is the middle item or middle element in the whole data set. So talking about the example, as you can see, this is not organized. This is not in sequence. This is not sorted. So we have to sort this sequence first. We have to sort this data first in a sequence. Let it be, let's say, ascending order. Usually we do it in ascending order, right? So when we align this data, when we sort this data in ascending order, we get something like this, right? 13 first, then 15, 16, 17, 18, 19, and then 20, right? So this is the sorted data in the ascending order. And the total number of items that we have, as I said, it is the 7 total number of items. Now, as you can clearly see now, since the data is organized now, and we have the sorted data, we can clearly make it out which is the middle one, right? If the data is less, you can visually make it out which is the data middle one. But if the data is huge, let's say we have around 70 observations, then we may have to compute what is the middle one, what is the middle value, right? So the simple term is, if the total number of observations is odd number, for let's say example of your fingers, let's say you have, in your palm itself, you have 5 fingers. So you can clearly point it out which can be your middle finger, right? But when we have huge data, let's say 70, right? Or let me put it in other way. When we have odd number of data, we can clearly make it out which can be the middle one. So let's say we have 3 values, you already know what is the middle value. When we have 5 values, we still know what is the middle value. Let's say when we have 9 values, you may have to think a bit more and you can still give me the middle number. When we have, let's say, around 21 values, you can still compute how many 20. Okay, 21. Then in one side there are 10, another side there are 10. So in between, that means 11th element is the middle one. So a little mind calculation will help you. But when we have huge data, let's say we have 71, we have 121, something 1081, something. So what I'm saying is odd number of data. You can still get the middle data by using this formula, which is whatever that total number is, n, let's consider this n, plus 1 whole divided by 2. Right? This 4 is just the number, that plus 1 divided by 2. So just to give the example of this, let's say we have 7 total items, wherein which makes n is equal to 7. So our median will be, let's say m will be 7 plus 1 whole divided by 2. So this 7 plus 1 is 8, 8 divided by 2 is 4. So the fourth term is our middle term. So the data, the total number of data was less, so we can you can manually compute. That's not a problem. But this formula will come handy when you have huge data, right? For example, as I said, 1081. So in that case, how can we compute the median? 1081 plus 1, which is 1082 divided by 2, that value, that whatever the value that we get, that term is our middle term. Now, please, one important aspect, very important aspect, which comes here is whatever the value that you get after computing in this formula, that is the value of your number of your item, and it is not actually the value that value. It's not that actual value, is the sequence in what you are computing. For example, fourth here, 4 is not the median, right? 4 is the fourth element or fourth item in the sequence. Now the corresponding value will be our median, right? So this is another mistake, common mistake, what people do in interviews, in different exams, tests, that they know what is median. They are very confident. They know what is median. They know how to compute average. They straight away compute the total number of items. They substitute. They know the formula. They substitute into the formula, and done. They get the value 4. They will select the option. Definitely, if there are multiple options in the question, if it's a MCQ question, you will definitely have one distracting value in the question to make your answer wrong. So let's say 4 is also an option there. So in that time pressure, people do this mistake to go and mark that wrong option, which was, according to you, you were not wrong. You assume that you did it right, but it was the whatever the value, the number that you got, that was the element or the item in that sequence. The corresponding value will be your actual value of median. Right? So I hope this point is very clear, that the 4 that we have here is the fourth item, and 4 is not the median here. Now what is the fourth item? 17. Now 17 becomes our answer for what is our median. So median becomes 17. So this is another very important aspect that I wanted to convey, and I hope this is conveyed. So any doubt so far? Let me come back to you. Any doubt that anybody want to ask before we move ahead with percentage? Let's have a quick doubt clearing session or question answer session, whatever you want to call it. But any point, any slide, particular slide that was not so clear, you want me to revisit it, clear some concept again, we'll do it right away before we move ahead to percentage. Yeah. Please, anybody having any doubt with respect to only average, you can unmute or put it in chat box, anything is fine. We will address that topic once again. Yeah, please, anybody, any doubt?
Sir,
Yes.
sir, in the problem you have taken 7 numbers, which is odd. We can easily find out. If it is even, then maybe example 6. Then can we use the same formula,
Okay, very good
which
question.
is
Yeah. Very good question. Very good question. So that was another point that we wanted to convey. That is, I gave you an example of your hand, right? You know there are odd numbers, odd number of fingers we have. We have 5 fingers, which is an odd number. So you know exactly middle number when we have three, when we have five, when we have nine, so on. But the problem is when we have even data, right? So when we have even data, how to compute the median in that case? So for example, let's say we have four values, right? We have four values. In that case, we cannot compute the median value, right? We can end up having something in between of those, but in that case, we don't have the corresponding item value to it. For example, let's say this seventh number is not there itself, right? This seventh items in the complete data set, the seventh item is not there itself. We have just only this data, the highlighted data which I have highlighted here, 1 to 6, and then question arises, how do we compute the middle number? Now, in that case is when you have this formula handy, right? Because in this case, if you compute for this uh, 7 items, you can clearly make it out that fourth will be the middle one, right? We have 3 items here, 3 items there. But the beauty of this formula is you can use this formula for the even number of items also. So when you compute the median for a data set which has even numbers of items in it, then this formula still can be used. But in that case, what will happen? Let's say when we don't have the seventh item, we have only the 6 items. So in our formula, it will be 6 plus 1 divided by 2, right? So that is nothing but 7 divided by 2. Now 7 divided by 2, when you do, you get a floating point value or a decimal value, which is 3.5, right? So in that case, how can you detect a number or an item? We don't have anything called 3.5 item. We have either the third item and its corresponding value, or we have the fourth item and its corresponding value, right? So 3.5 doesn't exist. So in that case, how do we compute the overall mean for that? So let me go back to the slide. Yeah. So in that case, let's say when we have this 6, we have another formula which is size of whatever the size is in the list divided by 2, right? The reason is because we have a even number of data set. So whatever we divided by 2, we will have a whole number, and that number will not be a floating point or a decimal type number, right? For example, when we have considered this 6 element, when we divide that 6 divided by 2, so in that case, the value that we get, that is 6 divided by 2, is 3. So that item number 3 and the corresponding value for that item 16 will be our median, right? So this formula, why I have taken this as an example is because even number you can divide it by 2 and you can find the average very easily, because you have the whole number. Anything divided by 2, matlab any even number divided by 2, let it be 2 itself, or 6 or 12 or 40 or 80, 100, they all are even numbers. So any even number, when you divide it by 2, you will get a whole number. There is no point of floating numbers. So in that case, it is easy to compute a median average. But problem that we face while we compute median averages, when we have even data set. So in that case, even data set, how do we compute a median? We have the size of it plus 1 divided by 2. So that is the reason why we do plus 1, is to make that data as even number. So 7 was added with 1 to compute 8, and then 8 was divided by 2, so that we have a value 4, and fourth item was selected as the median. Then we have the value of median, which is 17, as our answer. So I hope that this answers your question, that how or what is the formula to be used when we have even numbers. So in fact, even numbers data, if you have, it is much more easy, because you have to simply divide it by 2, and yes, you have the median average with you. But the problem that we arises, when you divide the odd number with 2, you have something in floating points, right? So that cannot be done. Then we cannot have a median in floating points. So we add 1 to it to make it a whole number, and then divide it, right? We make it a even number, we divide it by 2, then we have a whole number. So instead of 3.5, we have 4 here, and yes, we have a fourth element which has value 17. So that is the reason I took an example of a odd number instead of a even number. But good that you raised the question, because we never know our data has a even number of data or an odd number of data. Okay. So apart from it, I hope, first of all, I hope this answers your question. Does this answer your question?
Yes, sir. Yes, sir. Thank you.
Okay, Minaj, thank you. Anybody else with any doubt or any more clarification you would need with respect to averages before moving ahead with percentage? Anybody, any doubt? Okay, I got few messages in the chat box. Daya Mukher says that no doubt. Okay, no sir, fine, good enough. So I hope the very basic fundamentals of what is an average is clear with you. And since these lectures are recorded, very good that whenever when you're preparing for these quantitative aptitudes and you are dealing with the topic average, you can refer to these videos anytime. Go back to your basics, understand the fundamentals, because if you understand the fundamental, you will never forget. And when you never forget, you can solve any problems, whatever the level of difficulty is, when we encounter questions from the averages. So with this, we will come to our second part of the lecture, that is the percentages, right? So let me make it full screen. Right, let me quickly go back the slide, percentages straight away. Okay. So with this, I will start with the second part, that is the percentage. Again, very important percentage, as you must have seen so many questions in different examinations, right away in the interviews also, in the face-to-face interview also, and sometimes in the normal quantitative aptitude test before interview when they take. So there are a lot of actually very basic questions, very easy questions, but in that time pressure, in that placements, you can say environment, you tend to not precisely calculate the answer for it, end up marking the wrong answers, do some very silly mistakes like this, right? So again, like I said, the area of focus will be how can we understand right from basic, right from the meaning of what is a percentage to how to compute it. We'll have few example, how to solve it, right? So in our daily life, we have seen problems, so many problems which deals with percentage, right? Right, right way, taking an example, right, with you, students, we deal with percentage of marks, right? At every semester, after every IA, for every subject, we compute percentage, right? Then we talk about percentage in terms of profits and loss, right? How much percentage gain we got, how much percentage loss we suffered, or something like that. Then what is the percentage of shift or percentage of change, right? Percentage of discount, percentage of price. So many examples wherein we have this very important topic called percentage, which can be related to real time problems that we encounter, right? Percentage of let's say a company's progression, right? Any percentage of stock price, percentage of a market fall or market rise, so on. So there's so many examples you can relate to your own examples. The point is how important the problems which deals with percentages. So that is the reason I have taken these two very important topics, average and percentage, which are accurately related to our real-time daily life problems, what we see. So these are most common problems we sometimes neglect, right? But can be really very key factor from the placement point of view, and which can define your career, right? So that is the reason I selected these two topics. Let's move ahead and define first what is a percentage, right? So, in very simple terms, if I want to put it, it is calculating the percentage is one of the simplest and most useful of mathematical tricks, right? Whatever tricks it is. For example, a trick to find a performance measurement of a particular student. So we can simply find a percentage of his previous semester, the percentage of his next semester, the current semester, the whatever data that we have, marks, right? And then we can clearly see whether the candidate or the student has done well or gone wrong, whether his growth is into a positive direction or into a declining direction, something like that. So it's a simple mathematical trick to calculate or compute or measure few aspects into a mathematical domain. Fine. Now let's go a little more ahead and understand more of it. What is a percentage? It's the simplest way of quantifying the things. Now there's one more term that mentioned here. It's another simplest way to quantify the things, right? Quantify the things and presenting comparative ratios. Just to give you an example, a ratio of what was the percentage of profit over, or what was the percentage of loss in our overall transaction. That can be one example. So likewise, there can be many examples which can give us you know simplest ways of quantifying the things and presenting comparative ratios. Next is we will need to know how to calculate the percentage as it is concept used in almost every field. Like I give you a lot of examples like how percentage can be used right from your percentage of marks to percentage of a profit or loss. I'm talking in terms of management, right? Finance and those things. So you can relate it much more better. You can relate it to your subjects that you have learned in your management, and you can relate it to how percentage can play a role in that particular subject, right? So there can be different fields, and in every field there will be a factor of percentage definitely involved, right? So that is the reason, again, why we should know how to compute percentage. So let me first define this term. What is this term percentage? How did it come? What is the meaning of this percentage? And then we will have a simple example, a simple formula for it, and then we will compute it. Okay. So what is a percentage? As you can clearly see, this is how it is represented, right? But what is this percentage, right? So to define it, I want to divide this term percentage into two, that is percentage, right? So if you remember this thing, whatever I'm saying, whatever I'm discussing these things in the class, if you understand it, it will directly go in your mind, and I guarantee you will never forget these basics. And when you never forget these basics, and whatever a point in time, wherever in your life, whenever you are computing any problems, any solving any problems, you will recall these basics again, and then you can apply it to solve a problem, right? So when we discuss this term called percentage, you should immediately, the first thing that you come should come in your mind is percentage, right? Percentage. So what it means, it actually literally means that per, which you already know, centage. What is this centage? Centage is actually a cent, right? What is cent? Cent is something which can be computed in a figure in a terms of hundreds, right? 100 marks, or 100 items, 100 pieces, items, or whatever. So in terms of 100. So why the word cent? If you can recall, cent means the century. If you can recall century, right? One century is what? 100 years, right? So 100 years equals to one century. And 100 is a whole figure, you can say, which helps us to understand what is the portion, what is the ratio, and those other factors. So let's not get much into it, but it becomes much more easier for us to compute these things when we talk about in terms of 100. So that's why this standard is used, percentage. So whatever we'll be computing from now, we will be computing in terms of 100. 100 marks, 100 items, 100 pieces, and whatever it is. Right? So this is one way of specifying the fractions of a complete whole. This is just one way. There can be many different ways. It can be 200, it can be 1000, and so on. So this is just one simple one example. Now, in order to make you understand, I have a simple diagram here. You can see there are few blocks, some shaded, some not. Let's get into it and understand how this percentage value is a fraction multiplied by 100. What are we talking this thing in terms of 100? So when we talk about the percentage, it's the fraction, right? It's the portion. Portion of what? Portion of a bigger picture. Portion of whole thing. It's a small portion, a quantity, a fraction of the whole bigger picture, right? So this diagram, this box, this whole bigger square is just a single way of representing a fraction which is in terms of 100. Right? Let me put it here in terms of 100. Now, why I say 100? If you have observed it carefully, we have 100 cells in the column. Let me put it here. Sorry, 10 cells, not 100. 10 cells in the rows and 10 cells in the column. Right? 10 by 10, you can say. So we have something like 10 by 10. So that becomes our 100. So out of this 100, so we can definitely say that this is 100 blocks, 100 small blocks, and out of which few are shaded. Now what is this? Let's say we want to compute 15%. Okay, simple example, 15%, which is actually a 15 out of 100. So as you can see, 15 blocks are shaded here. These many blocks are shaded here out of 100. So this is our portion. This is our fraction, right? Now still we haven't computed percentage. Now this is just a fraction which can be somewhat represented like this, 0.015. Now, but what is the percentage of it, right? It means that this 0.15 is equal to 15 percentage. So this number 0.15, you can say that it is 15%, right? I hope this is clear. So 15% means 15 per 100. In other words, it is 15 per cent. This cent is century. Centuries, 100 years, right? So I hope you can remember this very simple trick, right? So just to give an example, this 15 blocks which we have shaded in green, this is the 15% of this box is green, right? You can say 15% of this whole block is green. So let's move ahead and discuss how to calculate this average, right? So don't I mean don't get bogged down with this so much text here. I'll just break it down in simple terms. Let's say we have few set of let's say we have a basket in which we have few fruits, few apples, few oranges, and few pineapples, and there are in portion, right? There are few, as I mentioned, there are few apples, there are few oranges, there are few pineapples. So when we talk about these few, this means we have fractions, right? We have a few portion in this. So what are these few fractions or portion? We have out of, let's say we have 20 fruits, let's say we have 20 fruits in our basket, out of which 5 are apples, 10 are oranges, and next again 5 are pineapples. So what can we call as a fraction is, this fraction is this total number of items divided by the whole quantity, right? So that quantity in this case is 20 here. So 5 divided by 20 is 1 by 4. So what is the fraction here? It is 1/4. So we can clearly say that apples are 1/4 of the total fruits that we have. Similarly, let's discuss the next, oranges. Now oranges are 10 out of 20 fruits, 10 are only oranges only. So this is, you can clearly say it's a half. Out of 20 fruits, 10 are oranges. So half of the fraction from our basket is, you can say, oranges. Now here again, let's third thing, that is a portion for pineapples. 5 divided by 20. Pardon me, here it is actually 1 by 4, right? So this should be 1 by 4. I think I just copy pasted the above line and forgot to change the value here. Anyways, so the portion is here is 5 out of 20, which is 1/4 of whole basket or whole fruits that we have in the basket. So 1/4 is equal to, if you can compute, 1 by 4 is actually equal to 1.25. And 1.25, as I mentioned, will be equal to 25 percentage, right? So we can say that pineapples are 25 percentage, and this is, so you can directly mentally calculate, half is nothing but 50 percentage, right? And again similarly 1/4 is 0.25 is 1/4. If you divide in calculator 1 divided by 4, you get 0.25, and the percentage that we get is 25%. So now you know how to calculate a percentage, right? Percentage can be calculated by first defining a fraction, and then that fraction can be converted into decimals and then percentages. This is one way. Of course, this is a simplest how a problem can be divided into very basic fundamentals, and then how can we compute percentage. But there are other direct formulas also to compute. So just to put it whole thing into a nutshell, how can we define a percentage using the formula? Like I mentioned, uh, you must have already come across this formula, which is something like percentage, whatever that percent that we want to compute, is equal to the part, whatever the part is the fraction or the portion, whatever the small part, those few fruits, those few marks, those few students, or whatever few example you take, divided by the whole set, right? And then we have to multiply that whole thing by 100, which is our percentage. Why 100? I already told you, it's a standard that we have maintaining for calculating a percentage. So taking the same example, the percentage of apple, as I said, it is 25%. The percentage of orange becomes 50%. The percentage of pineapple, which is 1/4, becomes again 25%. So when you compute this whole thing, add this whole thing, you get 100%, right? 25% plus 50%, 75, 75 plus 25, 100. So you get 100%. That completes our total number of fruits that we had in the basket, which is 20 fruits. Now 20 was just a number, but in terms of percentage, 100 percentage means 20 fruits, 50 percentage means half of the fruit, that is 100 fruit, 10 fruits out of 20. So with this, I hope the basics of what is a percentage is clear, right? So calculations of percentage, this is again the same thing, percent into whole. When you have to compute a percentage, when whole and percent are given in the question, right? Are given in the part that can be found by multiplying these two, percentage as well as the whole number. Now next is the percent. The percent must be put into a decimal form prior to being multiplied, and that can be done by dividing the percentage by 100. So this is nothing but the same example that we are talking about. 5 divided by 20 or 1 by 4, then we got, if you can recall, 1 by 4, we divided into the decimal, right? What we did, we uh, put it into a decimal form prior to multiplying. So let me put it into a decimal form. So this 1 by 4 will become 0.25, right? So now this is in decimal form. And once I have this decimal form, I have to multiply it with 100, which will give me 25 percentage. That's how we get this 25. So that's what this formula is uh, telling us. Now, this whole basic fundamentals, what we have done, let's understand with another example. Let's say one more example. Finding a fraction of a quantity. Okay. For example, find 4 out of 5 of 20. So it can be anything. Find 4 out of 5 of 20 students. Find 4 out of 5 of 20 subjects. Find 4 out of 5 of 20 marks. Something like that. So 4/5, we can say. Find 4/5 of 20. So simple trick to understand it is that replace the of with a multiplication symbol, right? When you multiply, when you replace the of symbol with multiplication, you get something like this: 4 by 5 multiplied by 20. So this is as good as 4/5 of 20. Right? Of is nothing but I'm just putting a bracket here. So 4/5 of 20. So when you compute it, 5 divides the 20, 5 fours are 20, and 4 fours are 16 that we get. So value that we get is 16, and that's how we get the 4/5 of 20 as value 16. Let's take another example. Let this be first one. Let's take another second example. Find 1/5 of 20. Now, 1/5 of 20, simple way to do is again, 1/5 is, let's say, 1/5 of 20 they have said. So that of will be replaced with multiplication symbol. So what I'll do is I'll just cut this 5 ones are 5 fours are, as you know. So 5, the final answer is 4. So 1/5, can say 1/5 of 20 is 4, right? So I hope this is clear, and this whole same thing is what I have put it into text here. So these are some different examples, just I have put it for you in order to understand, so that you can relate it to how it can be done. So for example, let's say, let me give you another example. 12% of 200, right? You must have encountered a question, right? Or you must have seen interviews, maybe online, or few mock interviews, when people might have asked, okay, gentlemen, tell me what is 20% of so and so number, right? So uh, you immediately get key, I don't have paper pen, and how do I compute it, how do I do it? So whatever it is, you have to just remember that whatever that number is given, let's say in this case 12% of that number, right? So percent, you have to remember that again. What is percent? Percent. So 12%. Now 12% of what? Of 200. So now what I'll do, I have created the formula. Now formula is ready with me. Now 100 is this, and this simply gets cut, and at ones are and twos are, and final answer that you get is 24, which is exactly like this. Now, but again you will ask me, okay, sir, this was so easy. This was a two. We had 200, so we just simply strike it out. All right. Let's take another example. So 40% of 270, right? 40%. The moment we encounter a question of percentage, the first thing that you know strike your mind is percent. What is percent? So 40% is nothing but 40%. Once you have this, now this 40% of what? Of 270. When you have this formula, your formula is ready. All you have to do is just compute. So when you compute, you have the answer. So I hope this is understood. And okay. Simple example: 35% of 40. Again, because the whole number here, the bigger number is less than the percentage, right? In all our previous cases, the number was big, the percentage was less. So in this case, the number is small itself. The percentage of the small number itself we are computing. So 35 percentage of 40. Now again, what is percent? It should be 35 percent is 100 of what? Of 14. So once your formula is ready, calculation is just, it's a simplest thing, right? You can just simply do it. Divided by 7, you do it, 2, you do it, or whatever, however you want to do it. Once you have the, once you have the formula ready, you can compute the answer, no problem. The problem that comes with the people most of the time is they are not able to bring that formula itself. What, where I have to substitute the values, what values we have to put in, which value will come under what, what is the denominator, what is the numerator, when I have to multiply, when I have to divide. So those things people go wrong there. When you understand the term itself, what that term does, what that term means, then you can clearly formulate the formula, I would say. You can by yourself formulate the formula. Once you know the formula, calculation is the simple game. You can do it. Anybody can do it, right? So once you are right in this, you can get the right answer as well, right? So that's all from the percentage point of view as well. So any doubt with respect to anything so far, whatever we have covered? Anybody? Okay, the comments says no. Anybody who didn't understood any part of the lecture and want to compute, or want me to compute any particular uh, problem that we have discussed? Any round? Yeah, please. If there are doubts, we will discuss it. Nobody has doubts. See, when there are no doubts, I always say to this to my students, when there are no doubts, there can be two possibilities of it. Either you have understood clearly, very good, or you have not understood anything. So I hope the first uh, case is the actual case, and I've tried my best to break the problem as small as I was able to do it, and discuss those smaller aspects, fundamental aspects, because For every problem, whenever you want to do any particular kind of problem, whenever you want to solve any problem, you have to understand this fundamentals first. If you know the fundamentals, rest is the game. That's it. Rest is the easiest game. uh, when the fundamental is clear, the question, let it be twisted in any way, let it be asked in any manner, let it be any level of difficulty. But if your fundamental is clear, if you read the question clearly, if you understand the terms used, of, buy, right, discounts, gains, right, profits, these terms, when you understand these, uh, percent, what is percent meaning, average, mean, discrete values. So when you read the question properly, you understand the question properly. When you understand it, you can relate it to fundamentals, whatever preparations that you have done. When you relate it to fundamentals, you can yourself formulate the problem, and when you formulate it, you are definitely going to get the right answer. You can get the ready formula for it by your own. You don't have to memorize a formula. You don't have to memorize कि if the average के problem, अगर average problem आ रहे हैं तो कौन सा formula मुझे याद रखना है, अगर percentages के आ रहे हैं तो कौन कौन से formula मुझे याद रखना. You don't have to remember anything if you are clear with the uh, fundamentals of what they mean, right? So with this, that brings to the end of my session. If you still have any doubts, you can reach out to me anytime, by any means. You have my details. Let me again share the contact details. Okay, I think I have to share the screen again. If you have any doubts with respect to these fields or any other topic, you can simply reach out to me for this email ID. Right, this is my college email ID. You can reach out to me, or you can reach out to through Ravi sir. However you are comfortable, that's not a problem. Fine. So with this, I would conclude my lecture and hand it over to you, sir. Ravi sir. Meanwhile, anybody having any kind of doubt, please feel free to ask.
No doubt, sir.
Okay.
No, sir, no doubt.
Thank you. Thank you. Okay, sir. So, I think we should then conclude, and I shall hand over it to Ravi sir. Ravi sir, over to you, sir. Am I audible to all? First of all, I think the session was clear enough because you were
Yes, sir.
responding.
Yes, sir. Yes, sir.
Okay. Maybe Ravi sir is using this meeting on phone, and he's on call, I guess. Let's wait for
Yeah,
him
hello,
to.
sir. Am I
Yes, sir, you're audible. Yes.
hello?
Yes, sir, you're audible, sir.
Hello? Yeah. Hello? Amrut, sir?
Sir, you're clearly audible, sir. No problem. You can go ahead. Over to you, sir.
Yes, sir. Yes, sir. I would like to thank Amrut, sir, from behalf of the MBA department as well as students for giving such a lecture on percentages as well as the averages, which would be very basic to understand, but would take you to a very uh, to solve a very complicated problems as well. So thank you very much, sir. And
Thank you, sir. Thank you for having me. It was my
would
pleasure.
like
Thank
to
you.
have such sessions in future as well.
Sure, sir.
Yeah, sir. Thank you very much. So with your
Thank you.
permission, I would like to end the call, sir.
Oh, definitely, sir. Thank you.
Yeah, yeah.
I
Thank
would
you.
thank all the participants for patiently listening, and I hope even one person, if it gets benefited, if these whatever small tips, whatever I've given, if they get benefited, I would say that this session is productive enough. So I would thank all the participants to
Yeah,
keep.
sir. Sure. Surely our students will make use of whatever tips and tricks I have told.
Yes, sir.
Yeah.
Okay. With this, I wish all the best to all the participants. So focus on polishing your skills, I would say. Thank you.
Yes, sir. Thank you very much.
Thank you, sir.
Thank you so much, sir.
Thank you.
Thank you, sir.